Hello everyone. Welcome to YouTube channel Energy Exergy Theory Applications. I am Tatiana Morozyuk and I am author of this channel. Today we are with the lectures on engineering thermodynamics. All lectures have a very dynamic style of presentation. Definitely some of you would like to learn more. We will be happy to answer your questions and provide with extended information. Please find our contact email in the description of this video. Today we continue with the second law of thermodynamics, and our topic today is entropy. Some people can say concept of entropy, engineers can say engineering function entropy. So now we will find out what in fact is entropy for the engineers. In the time when the second law of thermodynamics was discussed, definitely it was necessary already to calculate something. Because energy balance can be energy in, energy out, we already discussed that. We can give numbers for amount of energy that will be transported or transformed. If we discuss irreversibilities, definitely should be thermodynamic function or equation, a set of thermodynamic functions when irreversibility will be given the number, because we would like to compare higher irreversibility, lower irreversibility, and so on. In order to proceed with the mathematical expression of the second law of thermodynamics, Clausius proposed new function, which is called entropy. So he called this function entropy, and we will continue with the same name of the thermodynamic function. So as you can see from this slide, entropy was introduced in 1865, already very many years ago. In time of Clausius, only macroscopic approach of thermodynamic was under discussion. In that period of time, people who established the second law of thermodynamics, who discussed about that, they did not discuss micro thermodynamics or statistical thermodynamics. This came much later. It was already end of 19th century, beginning of 20th century. So we will follow fully idea of Clausius, how Clausius introduced entropy, and we will follow these ideas. So to understand the idea of entropy or concept entropy, we will look step by step at all postulates that were proposed in order to establish a new thermodynamic function. So, postulate number one, each thermodynamic system will have new extensive property, which is called entropy. So entropy is a new thermodynamic property of the system, and it is extensive property. We should remember that extensive means that this property depends on the size of the system. And the letter S was already used as a nomenclature for entropy, and units for entropy, it is joule per Kelvin. Postulate number two. The entropy of system changes if heat transfer will cross the system boundary or mass will cross the system boundary. So nothing is mentioned about work. So it means that concept of entropy can be applied for open system or for closed system, because I repeat, entropy will change either if matter will cross the boundary of the system, or energy, but thermal energy in form of heat. What will happen with entropy if energy in form of work will cross the system boundary? Entropy will stay constant. So it means that if theoretical work, without friction of course, will cross the system boundary, entropy will be the same. Nothing will happen with the value of entropy. And inside of postulate 2, we have the sentence that there is a new term which is called entropy generation, and through the term of entropy generation, we can express irreversibilities within the system boundary. Postulate number 3. How to calculate entropy? This is the most important for us. According to the idea of Clausius, entropy associated with heat transfer, it is heat divided by temperature of system boundary. So now we have new measure. It is not only temperature associated with the system, but also not temperature of the surrounding. It is temperature of boundary of the system. And we will follow the value of entropy generation. Entropy generation is always positive for all real processes, so means processes with irreversibilities, or can be zero if it is ideal process, means reversible process. Entropy generation negative cannot be. If in some calculations entropy generation is negative, can be the case particularly for the students, there is a rule: first, check very properly your calculations. If calculations are absolute correct, then something wrong with the system boundary. This also can be the case that for very complex system, we need to divide complex system to the smaller system, and we need properly to describe boundary for thermodynamic analysis. And now we have Clausius equation that later we will use very often for the complex equations related to properties of working fluids. Since entropy is extensive property, it means that entropy of the system consists of entropy of parts of the system, or we can calculate specific entropy, extensive property, specific entropy we can calculate, for example, on volume base, on mass base, even mass flow rate, or number of molecules, means per kilomole. And correspondingly, we will have the units for specific entropy, depends for which analysis we will apply and which value will be convenient for the engineers. Now, entropy balance. We already know the general form of all balances. We discussed mass balance, we discussed energy balance. Now we are with entropy analysis. Entropy balance is necessary to write as mathematical expression of the second law of thermodynamics. And change of any variables, transport plus generation minus destruction. And we already learned that according to the definition of Clausius, there is the term which is called entropy generation, means destruction will disappear from this equation. And we have equation already with the mathematical equation, entropy at state 2 minus entropy at state 1 means state 2 and 1 of the system. It is entropy transfer through the system boundary and entropy generation. Here in the equation, you can see the word transport. Here it's written entropy transfer. It is not so important for us because even in some terminology, transport and transfer associated with energy conversion system can be even synonyms. So that's why we will not pay attention to the different in these two words, because meaning will be the same. So why it is integral here? Because it can be the case that a system is not with homogeneous shape, and we need to consider different parts of the system because it is different shapes and can be different properties and can be different boundary conditions, and definitely different amount of heat transferred from different part of the thermodynamic system. And equation that we just discussed now, and I will show you something not only with this slide, but also with some sort of in-hand explanation. It is a funny doll, does not matter. You can see that I can say it is energy conversion system or it is thermodynamic system. So, and the system has a very complex shape, and as you can see, even different colors, different materials. So if I would like, let's assume that heat will be transferred from system to surrounding, and definitely I need boundary conditions. And according to human psychological approaches, we always say boundary conditions, it is really physical boundary of this system. So, or with technical system, here with abstract, you can see that in gray color is the shape of the system, and in red color, it is physical boundary of the system. And in this way, definitely we need integral, because we should divide this very complex shape or this complex shape into different parts, measure heat transfer through each part to sorting, and definitely boundary conditions temperature will be different. So it is very complex to do this even now with experiment, and for some cases it is almost impossible, and definitely it is not a good approach for the engineers. How to proceed to apply entropy transfer term for the engineer? How to calculate? Very simple. We need to change the location of boundary, because boundary, it is our decision what we will include to the boundary. Again, I will use this figure. So no one pushed me to use boundary exactly as shape of the system. I always can put to the boundary a little bit environment. Like in package, like in transparent ball, I will include a little bit environment, and the situation will be like that. So it means that system plus a little bit environment included, and only after that will be boundary conditions for the evaluation. And temperature of boundary condition, it is environmental temperature. And it means that using such boundary conditions, and as I told you, we're engineers, we can assume any boundary conditions, it is our decision. Immediately this equation will be easier, because we don't need integral, we can have total heat transfer from the entire system, and environmental temperature, because boundary conditions will, so boundary will be with environmental temperature, so it will be boundary conditions too. To discuss, we will discuss this further, and this will be very important assumption for us already in exergy analysis and even for evaluation of real energy conversion systems. So let us repeat. We have the third term here, entropy generation, and entropy generation can be zero if no irreversibilities, means ideal process. Entropy generation is positive for irreversible processes, means for all real processes. Entropy generation negative is impossible. What is very important for us to remember, that entropy generation, it is not a state property, it is characteristic of the process. This is very important for us to remember. Entropy generation, this term, will describe irreversibilities within the process. I know that in different books in thermodynamics with different languages, sometimes the term entropy generation is written like a delta S. It is mistake. Definitely it is mistake. Delta S, it is just change in entropy. It is left part of equation. Entropy generation, it is one term in the right part of equation. So if someone saw such a I can say typo in books, please pay attention to that and try to follow classical thermodynamic approach. That term entropy generation, it is not a state property, it is characteristic of the process. In some books, instead of entropy generation, you can find the term entropy production. This can be the case. Okay, entropy generation, entropy production, in general, it is the same, and this we will not pay big attention to two different words. Entropy balance. Definitely entropy balance we need to discuss for open system and for closed system. So regardless which system we will discuss, for both kinds of system, we will introduce so-called boundary conditions too, so that our analysis, engineering analysis, will be simple, because now all boundaries will be with the temperature of the environment. For the closed system, entropy balance, we already discussed it before. It is associated with the change in entropy of the system, associated with transfer or of energy in form of heat through the boundary of the system, and for all real processes we have entropy generation as a result of irreversibilities. And the entropy balance for open system, it is the same two terms, but also we need to consider entropy associated with the matter mass flow rate of all material streams coming to the system, crossing the system boundary, and going out from the system boundary. In this equation, of course, classical nomenclature uses CV, means control volume, but we always use the term open system. It is the same, it is synonyms. If you found this lecture interesting and useful for you, please give a like to this video, subscribe to the channel, and share the link with your colleagues. Our next lecture, lecture 6, we will continue with the second law of thermodynamics, and we will discuss Carnot theorem and Carnot corollaries. Thank you.